Hello, 2.4 projectiles at an angle. So now we're going back to what we did earlier in the module. So we're going to need that SOHCAHTOA there to help us out. Okay, so if you have not yet put that in your notes, SOHCAHTOA. So anytime we're dealing with an opposite and a hypotenuse, we're going to be using the sign. Anytime we're dealing with the adjacent and the hypotenuse, we're going to use the cosine. So with these projectiles, 99% of them are going to be in the positive direction. So when you split it off, the x is the horizontal. Okay, and so that would be your x side, and your y is your vertical. And it does not matter if we're talking about a distance or a acceleration or a velocity. Vertical is your y, horizontal is your x on projectiles, as long as they're shooting it off in the positive direction. So then our angle, whenever they describe an angle, would be the angle here. This is the angle with the horizon, sometimes they say, or the angle as it was tilted up. Any of those type of words would apply to the same thing. So I notice the horizontal is on my adjacent side. And the y vertical, you're like, whoa, that doesn't show me that the y is on the opposite. But remember, the cool thing about vectors is I can take this whole vector and I can redraw it over here to make my triangle. So if you don't see a triangle, you can shift an item until you find it. I would shift the one without the angle because this angle is already connected here. And so that you don't have to make sure that you're subtracting 180 or subtracting 90 to find the angle. So the y is also going to be on this side. So you can apply the y on the left or the right or the horizontal. And that's where you can then see, oh, y is going to be my opposite. So for this part, sine is typically going to be your y, and cosine is typically going to be your x. Not 100% of the time, but it is a good start for these ones. Remember, it can say the velocity initial is equal to velocity naught. It could use either one of those things. And in this case, they're not going to be zero because we're going to give you a resultant velocity with a number. And you're going to have to break it down into its x and y components. Or they're going to give you the x component and the y component, and you're going to have to figure out the resultant. Same thing we did earlier in the chapter. So how do we do that? This guy is my adjacent. So cosine of theta is equal to adjacent over hypotenuse. That's my CAH. Let me put it into terms again. Cosine of theta is equal to my vector in the x direction over my resultant vector. So if I want to solve for my x direction, I'm going to multiply VR on both sides. So the velocity resultant times the cosine of theta is going to give me my velocity in my x. So that's an important formula to have written down. How about my opposite? Say this guy is opposite. Remember, the hypotenuse is always going to be the longest one, so that's always a good double check. And then the one that's associated with one side of the 90 or the other, this one's the far side, so we call that the opposite. And that would be sine of theta is equal to opposite over hypotenuse. And now let's plug in our numbers. Instead of opposite, I'm going to put vector in the y. Instead of hypotenuse, vector resultant. I'm again multiplying both sides by VR so I can get VI by itself. VR times sine theta is equal to Vy. And again, another important formula to have written down, and make sure you're in degrees. If you're using Desmos, don't use the graphing one. Make sure you're using the scientific one. That's also going to help you out with the arc signs. So what is the tangent of this angle? Tangent is equal to opposite over adjacent, Vy over Vx. What if they don't give us the angle and we have to solve for the angle? Then you take the tangent of -1 or the arctan, and what you do to one side, you do to the other. So the tangent of the Vy over Vx is going to give you your theta. How do you plug this in? Your Vy number divided by your Vx number, and then hit the tangent -1 on your calculator, and that's going to give you your theta as long as you're in degrees. Or if you're in Desmos, make sure, again, you're in the scientific part of Desmos, and then you can just type that in to find your answer. So how would we solve this problem? V in the x would be the resultant times the cosine of theta, because x goes with cosine. So if my total resultant is 22.1 and my angle is 30.5, 22.1 times cosine 30.5. How about the vector in the y? Same exact statement, except for the sign, because it's the opposite side. And when we're on the opposite side, we use the sign. So another little review there. Hopefully that's starting to sink into place now. Let's do some problems. Ski jump has an angle of 35 degrees, so that's my theta, to the horizontal. If the jumper launched at 47, that is my resultant vector. It doesn't say launched horizontally, launched vertically. It launched at an angle, so we know that's our resultant. How far away is he if the trip took 2 seconds? Right? Draw a picture every time. Get in the habit of drawing a picture. 47 is on my resultant side, and my theta is down here at that acute angle closest to where the ski jumper started. And again, just start using just boxes for those, because that's going to help you out later on. How far away did he land? Okay, so how far away did he land? I want to know this distance in the x, which is my range. So what do I know? Okay. If I want to do my distance in the x, I need my velocity in the x. Okay. Velocity in the x times time is equal to my range, because the range is the distance in the x. So you have to make sure you're matching. If I want dx, I need vx. If I wanted the distance in the y, or the altitude, or how high he went, then I would have to make sure I was using the velocity in the y. You gotta keep them separate. Okay? So this one, I'm gonna need my velocity in the x. Okay? So what is my velocity in the x? The velocity is the one that's nearest. So it is going to be the cosine, 47 cosine 35. And then if you wanted to find Vy, that'd be 47 times sine of 35. What is the horizontal distance formula? That's the range formula. So that's what I have right here. So what do I know? This velocity in the x is 47 cosine 35. And my time was given to me is 2. So I'm just going to multiply those together. Be very careful that you have the cosine 35 in its own area, or else it's going to give you the cosine of 70, because you might have said 35 times 2. That is not going to work. So if you're checking out your answer, here's the answer down there, 77.00 seconds. Okay, ski jump has an angle of 35 to the horizontal. If the jumper launched at 47 meters per second, what is the altitude? So same problem, we just want an altitude. So we have that. Do not use the time from the last problem on this one, because you don't know if it's the same time, and it's not. Let me just tell you right now, never use the information you got from another problem unless it's an A, B, C, D, and they want you to build. So start from scratch. We want an altitude. An altitude is a distance in the y. So I'm going to need the velocity in the y. Velocity in the y is opposite this angle. So I'm going to use the sign. So that would be 47 times sine theta, or sine 35, is going to give me my velocity in the y. If you wanted velocity in the x, 47 times cosine 35 because Vx is on the cosine side or on the adjacent side. What do I need now? I need an altitude. So I need an equation. Go back to those same 3 equations from module 1 and see if you can figure out which one to use. So here are those equations. What's this going to help me? And again, this equation is the same for dy or dx, but in this case, I need dy. So I'm going to need the velocity initial in the y and the acceleration in the y. The velocity final squared in the y, the velocity initial squared in the y, and the a in the y to get the distance in the y. So every single time you do this, make sure you're matching. That distance in the x would not have given me the right answer. Everything has to match. Distance, velocity, and acceleration in the y. The time has to be the proper time, but most of the time you'll find out there are some rules so that you can equate the time. So what am I looking for? The distance in the y. So I'm going to underline that. I'm going to underline my unknowns. And I'm going to circle my knowns. Okay? My givens or my knowns, the variables I already have an answer for, I'm going to circle those. Velocity initial in the y direction. That's what this guy is, okay? Because he was shot off at 47. So this isn't talking about the velocity at the halfway point or at the end. It's talking about it at the initial. Do I have a time? I do not. Do I have an acceleration? I do. We're going the opposite direction on our acceleration because gravity is pulling me down, making me slower, so it's negative. How about this guy? Velocity final in the y. Let me think about that. If I want the maximum height, then my velocity y final is going to be equal to 0 because we went all the way up and then all the way down. So we started at 47 sine theta, got slower, slower, slower until we were 0, and then we sped back up on the way down. So for finding the height, I'm going to use the velocity final squared. I know my velocity initial squared. I know my acceleration, and that leaves me my distance. So I got to use that second formula there. The first formula is not going to do me much good. Velocity final squared is 0 squared is equal to velocity initial squared. That is my 47 times what? Sine of 35, because I need my velocity in the y direction, plus 2 times acceleration in the y direction. What's pulling me down? Gravity. I'm going up and gravity's pulling me down. Those are opposites. So another reason to know it's 9.8. And then my d. And then I'm going to solve that for d, and I get 37.08 meters for my distance in my y, or my altitude, or my height. So you could see any of those questions on there. But there's that answer if you want to check and make sure that you are solving your algebra correctly. And that's all. We'll start with some harder ones next.